with number 47, how many moles of gold are present in the cube? And we've got option A, 9.8 times 10 to the minus 14th moles, B, 9.8 times 10 to the minus 8th moles, C, 9.8 times 10 to the minus 5 moles, D, 9.8 times 10 to the minus 4 moles, or E, 9.8 times 10 to the minus 3 moles. So again, it's going to be an order of magnitude answer. And we're going to have to go over with what we're given, which is we have 1.93 times 10 to the minus 5th grams of gold, which we've already found. And now I have to convert from grams of gold to moles of gold. And it turns out that the given molecular weight is 196.97 grams. And we're going to need to put this in scientific notation. So this is, there is 1 mole of gold divided by 1.97 times 10 to the squared grams, or 1.97 hundred grams. This is 197 grams of gold. So once we have it in this form, it becomes a trivial matter. Now let's go ahead and extend this. This is equal to, here's my mantissa information, 1.93 divided by 1.97. So there was a typo on the key where I have 1.98 times 10 to the minus 5th divided by 10 squared. Well, the rules of exponents, when I multiply, I add, and when I divide, I subtract. So it's 10 to the minus 5th minus 2. So that'd be minus 7 times 10 to the minus 7 moles of gold. And now we can take the information given, which is this is equal to 0.98 times 10 to the minus 7th moles of gold. And now this is not the standard format. We have to have some number between 1 and 10. So that would be 9.8 times 10. And now I move the decimal point to the right. So that means it's going to go from minus 7 to minus 8 moles of gold. And so our answer is 9.8 times 10 to the minus 8. So the order of magnitude is minus 8. And let's see which one of these. Well, option B is the right answer. And so now for number 48, how many atoms are present in the cube? And the options are A, 5.9 times 10 to the 20, B, 5.9 times 10 to the 21, C, 5.9 times 10 to the 19, D, 5.9 times 10 to the 10th, or E, 5.9 times 10 to the 16th atoms. And so let's go and see what we've got. I've got 9.8 times 10 to the minus 8 moles of gold, and there is 6.022 times 10 to the 23rd atoms for every 1 mole. And so that's going to be equal to, well, we'll multiply the mantissas together, 9.8 times 6.022, and that is times, and now 10 to the minus 8 times 10 to the 23rd. Okay, 23 minus 8 is 23 23 minus 8 is going to be 16, isn't it? 16, nope, 15. It's going to be 10 to the 15. And that would be atoms. And that, we got to take this mantissa information, and it turns out 9.8 times 6.02 is equal to 59 times 10 to the 15 atoms. And that we have to convert to proper scientific notation, so I have to bring this decimal point over 1, moving it to the left this time. So that means I'm going to increase this. It's going to be equal to 5.9 times 10 to the 16th atoms. So it's all about knowing when to add and when to subtract, or when to add or when to multiply. And this turns out to be our order of magnitude is 10 to the 16th. Which of these answers? They're all 5.9, but 10 to the 20th, 10 to the 21st, 10 to the 19th, 10 to the 10th, 10 to the 16th. So option E is the right answer.